A 99% of us live unaware of Earth's slow motion collapse. To our continents are rafts adrift on a molten sea. But this constant churn dictates the planet's very future. Our tectonic plates are massive, rigid slabs colliding constantly. These ancient battles sculpt the tallest peaks we see. Geologists map this dance using deep-sea sonar. Where plates pull apart, new ocean basins are born. Heat escaping from the core drives the entire system. Earth has assembled supercontinents before, most famously Pangaea. The Atlantic Ocean is currently widening by centimeters yearly. Now that we understand plate mechanics, let's explore the future. Scientists predict a new assembly Pangaea Proxima is coming. But this future supercontinent forms in roughly 250 million years. The massive Pacific Ocean will ultimately be erased by convergence. But this closure involves extreme compression and continental stacking. Africa's northward push will seal the Mediterranean Sea. The mantle flow underneath determines the direction of collision. But Pangaea Proxima will be roughly circular, centered globally. But this configuration has profound implications for global climate. A single landmass means immense distances to the coast. But the interior deserts will likely become extremely hot and dry. Moisture-laden winds will struggle to penetrate that deep interior. But ocean currents will be drastically different, impacting heat distribution. Subduction zones will remain highly active, fueling volcanism. These eruptions will pump massive amounts of gas skyward. This input significantly alters the greenhouse effect dynamics. But North America's fate involves a dramatic westward thrust. The western coasts of continents will see massive mountain building. The process isn't uniform as some areas remain stable longer. Imagine the life forms that will evolve in this environment. The rock record of Proxima will tell an incredible story. Pangaea Proxima is the third major supercontinent cycle predicted. The key drivers are slab pull and ridge push forces. A ridge push occurs as new crust elevates the seafloor. Understanding these forces helps us predict planetary evolution. Continental crust is thick, oceanic crust is dense and thin. Every mountain range holds memories of a prior collision. The deepest trenches mark where crust is recycled back down. Even small microplates contribute to the larger continental puzzle. The Americas, too, follow the inexorable pull toward Proxima. On the edges of Proxima will be defined by intense seismic activity. Rocks themselves change structure under these deep lithospheric stresses. But the climate models suggest an even harsher hothouse Earth scenario. A less ocean surface means less heat regulation globally. But coastal regions will experience massive tidal swings and weather. This single configuration will dominate Earth's face for eons. I recall that this assembly follows the breakup of the last one. And every second brings the continents infinitesimally closer to Proxima. Seismic monitoring confirms the underlying consistency of these models. The ancient cratons are the anchors resisting this massive movement. The oceanic lithosphere is constantly being consumed and renewed. The engine driving this is not static, it evolves over time. The final ocean, Pangaea Proxima, will be vast and deep. The unimagined mountains far higher than any we know today. But the process of rifting and closing is cyclical, not linear. A Pangaea Proxima represents a temporary, grand stability. A life there must adapt to massive climatic extremes daily. Even Australia races north, destined for a violent merging. The boundary lines blur as the planet achieves its next form. The future is certain. The Earth's crust is always in motion.